Let us solve a question that was asked in GM Economics paper of 2022 regarding linear programming problem. The question is like this: let the linear programming problem be maximize z is equal to minus 0.2 x1 plus x2 subject to the constraints 2x1 plus 5x2 is less or equal to 70, x1 plus x2 is less or equal to 20, x1 and x2 are greater or equal to 0. If x1 is equal to a, x2 is equal to b is the optimal solution, then what is the value of x plus b? Okay, we have to find out the solution of this very question. That means sum of the x1 plus x2, which are the optimal solutions. Okay, how do we solve this question? So let's take these inequalities and change them into equalities. Okay, so we have 2x1 plus 5x2 is equal to 70. Okay, first step is to change the inequalities into equalities. Now we will also graph this out. Okay, so we will graph this. Let us put x1 is equal to 0. If we put x1 is equal to 0, our x2 will be equal to if this stuff is 0, so x2 will be 70 upon 5. So this is 70 upon 5 is 5 ones are 5, 6 is 7, 5 fours are 20. Okay, then put x2 is equal to 0. Okay, now in secondly we put x2 is equal to 0, so this whole stuff becomes 0. That means x1 is equal to 70 upon 2, that is 35. That means x1 is equal to 35. Okay, so let's graph these two pointers here. So the pointers here are 0, 14, and here we have 35, 0. Okay, so let's graph this out here. So we have 0, 14. Let us say this point is denotes our 14. Okay, and we have 35, 0. Okay, let us say this is our 35, 0. This will be the line for this 2x1 plus 5x2 is equal to 70. Now take another x1 plus x2, x1 plus x2, change this inequality into equality, is equal to 0, is equal to 20. Similar procedure, put firstly x1 is equal to 0. If we put x1 is equal to 0, which implies x2 will be equal to 20. Okay, so 0 plus x2 is equal to 20. Now put x2 is equal to 20, 0. If we put x2 is equal to 0, which means x1 is equal to 20. Okay, x1 is equal to 20. Okay, so then the pointers will be 0, 20 and 20, 0. Okay, let's graph them also out. So we have 0, 20, that means this will be our 20. This is obviously x1 here. We have x2 on this axis, so we have 20 here. We have this point 0, 20. I guess I have drawn this also incorrectly here. Okay, I apologize for these horrendous mistakes. So we have 0, 14, so 14 will be here. First coordinate is also for always for x-axis, and second is for y-axis. Then we have 35. So this is like this. We have 35 here and 14 here. Okay, so secondly we have 20. So let us say this is 20 on this let us say this is the 20, the point 0, 20, then we have 20, 0. So this will look like this. I should have drawn it with another color. Okay, so we have here 20. The coordinates obviously are here 20, 0 here, and the coordinates are 0, 14. Okay, I am just writing them. So the coordinate of this point is 0, 20. So I will write here 0, 20. Okay, now let's try to find out the coordinate of this point, okay, where these two lines intersect. For that, what we need to do, simply take these two equations. Let us say this is equation first, equation second, solve them for x1 and x2. How can we solve? So if we multiply this equation both sides by 2, so this equation will become 2x1 plus 2x2 is equal to 40. And originally we have this equation 2x1 plus 5x2 is equal to 70. Now subtract them, or we can subtract them here. Okay, so 2x1 2x minus 2x1 gets cancelled, so 2x2 minus 5x2 comes out to be minus 3x2 minus 40. 40 minus 70 comes out to be minus 30. So negative sign gets cancelled. X2 is equal to 30 upon 3, which means we have 10 as the value of x2. If x2 is equal to 10, okay, then what will be the value of x1? So we have 2x1 plus 5, the value of x2 is 10, so I can write it here 10 is equal to 70, which means 2x1 is equal to 70 minus 50, or x1 is equal to 70 minus 50 is 20 upon 2, which comes out to be 10. So the coordinates of this point are 10 and 10. Okay, and what is our feasible region? Feasible region is that very region which is bounded by these two lines. Okay, so this region, the common region of these two lines, what we call this is the feasible region. Okay, in the feasible region we would have the optimal solution. Okay, what is the feasible region? Feasible region is the region which is bounded by the two lines, which is the common region here. Okay, and since we have x2x1 plus 5x2 less or equal to 70, so this will lie inside this box here. Okay, if it was greater than 70, then our feasible region would have been upwards. Okay, so this is our feasible region. Now we have 3 points, and at these 3 points we need to find out what will be the maximum possible value of x1 and x2, which gives us the maximum value of z. So what are the points we need to focus on? We have 0, 14, then we have 10, 10, and then we have 20, 0. Okay, just plug these values into our objective function. So what will be our z then? So we have minus 0.2, the value of x1 is, so let us write this is x1, this is x2. X1 is 0 and x2 is 14. Okay, we are checking at this point. Okay, let me rub this out, and this is 14. So 0 times this negative number is 0, so we get here 14 as the value of z. Let's try to figure out at this point, when x1 is equal to 10, x2 is equal to 10, at this point what will be our z? Just plug, we have minus 0.2 into 10 plus the value of x2 is also 10, so this is minus 2 plus 10, so we only get here 8 as the maximum value of z. On this point, let's plug again. We have minus 0.2 minus 0.2, x1 is 20 plus 0, x2 is 0, so I can write it here. So we have this will be a negative number, it will be minus 4. Okay, from these 3 points, this point, this point, and this point, the maximum value of z occurs at this point. Okay, z is maximum when x1 is equal to 0 and x2 is equal to 14. Okay, then so x1 will be equal to a, x2 is equal to b. That means our x1 is equal to 0, x2 is equal to 14. Okay, so we have 0 plus 14, which will come out to be 14. That means the maximum or optimal solution to this question will be equal to 14, and the optimal values of x1 and x2 are 0 and 14. So we got here this very point is the solution. Okay, I hope I make myself clear. Thank you.